Peace be upon you, dear children. This is our first chemistry class. And dear children, you're sitting in front of me after opting science stream for your higher studies. Then tell me, what is science? Science is the systematic study of our nature, our surrounding. This science is being divided into different branches: physics, chemistry, biology, and geology. Physics is the study of different forces. Biology is the study of living beings, plants, animals, all this. Then geology is the study of earth. Then now we are sitting in chemistry class. We should know what is chemistry. Chemistry is the study of structure, composition, and properties of matter. Matter means anything that has mass and needs space to occupy. Anything like this marker, this cloth, and mobile phone, this kind of board, anything, the table, chair, anything that has mass and needs space to occupy. The air, the gas in LPG cylinder, liquefied gas, all these are matter. And this matter, later the scientist has proved that all this matter or any matter is built up of minute particles, and it is called as atoms or molecules. So we can say chemistry is the study of atoms and molecules. It is also correct. And many possible definitions are there. Study of chemical reactions, all are correct. Okay, then this chemistry plays very important role in our day-to-day life. In your childhood, you might have wondered how these vehicles are running using fuel and how we are getting energy from the food, and how these different types of things, what we can say, the plastics, all these, how these are being made. Many questions might have wondered you. Then these type of questions could be answered by a single word: chemistry. Chemistry plays a very important role in predicting weather patterns, in the production of plastics, then acids, bases, alkalis, and dyes. Dyes makes our life colorful, and all this kind of items, right? And very important thing, the medicines. In the field of medicines, for example, cisplatin used in the cancer therapy. The discovery of such medicines made a historical change in the field of medicine. And at present, in different laboratories, scientists are doing researches to discover an effective vaccine against COVID-19 virus, right? So here, in all these fields, chemistry plays a very important role. And in the different types of foods, then food preservatives, then sweetening agents, then cosmetics, toothpaste, soap, all these are products of chemistry, right? So chemistry is very important, and the study of chemistry is intertwined with the other branches of science, right? These all branches are interrelated. Okay, and This study of chemistry make it possible to discover what we can say superconducting ceramics, then what we can say that substitutes for some harmful uh, refrigerants. We cannot avoid it from our day-to-day life, but by understanding the structure and composition of this chlorofluorocarbon, means CFCs, used as refrigerants in refrigerators, air conditioners and all this. So by understanding their composition and structure, it is possible to make a substitute for this, which is harmless to our environment. Actually, how the CFCs are harmful to us, because these causes depletion of ozone layer and it makes long-term harmful effects. Right? Okay, so the scientist has been succeeded in discovering substitute for CFCs. Right? So in all these fields, chemistry is very important. And if we are continuing to speak about the benefits of chemistry, it is actually endless. So now we can move the basics of chemistry. Chemistry is the study of matter, means study of composition, structure and properties of matter. This matter, based on the arrangement of constituent particles, are being divided into three types: solid, solids, liquids and gases. Okay, this are called different physical states. In solid state, the particles are very closely arranged like this. So there is no space between, very small space between particles. Right? They are very closely packed. Okay. And because of this closely packed arrangement, the particles are restricted to move. They cannot move. They are restricted to move and they can only oscillate about their main position. Okay, and because of this, the solids have definite mass, definite volume, definite shape, all this, right? And in liquid state, the particles are not much closely packed. There is more space between particles compared to this solid state. And these particles are free to move about. And because of this, they have a definite mass and definite volume, but no definite shape. They accuse the shape of the container. Okay, and then in gaseous state, the particles are more free to move. They have definite mass till now because they are matter, but they don't have definite shape, definite volume now. They occupy maximum space available for them. Okay, and for example, one matter can exist in these three different states. For example, ice, water and water vapor. These are three physical states of one matter, and these physical states are interconvertible by adjusting the temperature and pressure. Right? How we can convert ice to water? By increasing the temperature, and water to ice by freezing, that is by decreasing the temperature. And how we can convert petroleum gas into liquefied petroleum gas, that is to liquid state, by decreasing temperature as well as increasing pressure. So by adjusting the pressure and temperature, we can one matter can be converted into different physical states. Okay, that's all about physical states. Next, matter again classified into two: mixtures and pure substances. Right? Mixtures means it contains contains more than one components. Right? There will be two or more components. And this mixtures again classified into homogeneous mixtures and heterogeneous mixtures. These you have learned in your 9th class about mixtures, solution, colloid, suspension and all this. Right? So solutions, for example, salt solution, sugar solution, all these are homogeneous mixtures because in these mixtures the components are uniformly distributed throughout. Right? But in heterogeneous mixture the components are not uniformly mixed, not uniformly distributed throughout. For example, kerosene and water. Kerosene plus water. It will remain as two layers. It is not uniformly distributed. The components are not uniformly distributed throughout. Such a mixture is called the heterogeneous mixture. Then sand and mustard, if we mix it together, it is easy to see separate components, right? So such components are called the heterogeneous mixture. And colloids, milk. Milk is actually, it looks like homogeneous mixture, but it is actually a heterogeneous mixture. Okay, then next, pure substances. It contains only one type of component particle. These can again be classified into elements and compounds. Elements, I will write you example: sodium, magnesium, then neon. In all these elements, the constituent particles are atoms. That is, their minute particles, the most minute particles are atoms. But in case of elements like Cl2, O2, etc., in these, their constituent particle, that means their building particles, minute particles are not atoms, they are molecules. They are made up of Cl2 molecule, O2 molecules. But they contain same type of atoms combined to form molecules. This is the one type of pure substance. Then in next type of pure substance, compound. It contains more than one type of elements. Okay, but their constituent particles are molecules, but they are compound molecules, means they contain more than one elements. For example, H2O. H2O, it contains two elements, hydrogen and oxygen. Then NaCl. NaCl, it contains sodium and chlorine. So this is a molecule, but it is a compound molecule. And this is another molecule, but it is not a compound molecule. Okay, in other words, H2O is a compound, and hydrogen only if we are considering that is an element. Okay, and in one another way we can say this compound cannot be separated into its constituent atoms by physical means, but in mixtures the components can be separated into their constituent particles by physical methods. Okay, these in mixtures their components can be separated by physical methods. but in pure substances it is not possible. That is one important difference between these two types of matters. Okay, next we are going to see properties, physical and chemical properties. Physical properties means observable properties. Such properties, when we are measuring, it will not change the identity of the substance. Okay, for example, if you are measuring its length or weight or its melting point, for ice, if we are measuring its melting point, we can increase the temperature, but its composition will not change. It will remain as H2O itself, right? So such a property is called a physical property. But chemical property means chemical change, right? For example, if you are checking whether a given substance is combustible or not, that means അത് തീ പിടിക്കുമോ ഇല്ലയോ എന്ന് നമ്മൾ നോക്കുകയാണ്. So for that purpose we want to burn it. At that time it will be changed to other substance. We cannot get back the first substance, right? So such a property, we are measuring whether it is combustible or not. Such a property is a chemical property. Okay, so this physical properties, observable properties, and if we want to measure, if we in our day-to-day life we want to measure a lot of physical quantities like length, mass, volume, all this, right? In very olden days there was not such a standard system for measuring all these physical quantities. Before 18th century there was two systems, English system and metric system, in different parts of the world. So in one part they are using one system for measuring length, mass, etc. But in another part of the system they are using another system, right? So they are measuring in some other unit like a yard, something like that, right? So it made confusion. When more communication between different countries started, they decided it is better to have a standard system for measuring physical quantities. So after 18th century, one standard system of units came into action and it was accepted. Still it is accepted all over the world. That is what is called the standard system of units, or SI units. Standard system of units, but it's in its short form. S comes first because in French it is read as Les Systèmes Internationaux Units. Okay, that's why S came first. So in international system of units, they considered 7 physical quantities, right? And they fixed some units and symbols for these 7 quantities, right? And it is being accepted throughout the world. Still we are using this as our standard unit, right? So if we are dealing with very minute particles, we use some other unit, but what is the standard unit that is for one quantity is always accepted throughout. Okay, let us see which are the 7 quantities considered in this SI system. One, length, then mass, time, electric current, temperature, amount of substance, luminous intensity. And these are the symbols for these quantities. Okay, quantities are given the symbols. For length, L, and its unit meter, and the symbol of unit M. In this way, for mass, the symbol for physical quantity mass is M. These symbols we use in physical equations. Equations in our doing problems like physics, in physics as well as in chemistry. If we are if we are using some equations, there we use these symbols. These are the standard symbols for these physical quantities. Okay, and their units are given here: meter, kilogram, second, ampere, Kelvin, amount of substance mole, then luminous intensity, candela. Then their units. Unit can be represented in short form like this. Meter can have the shorter, we can denote it by M. Then kilogram by kg. All this second time having standard unit second. Yes. Then electric current ampere, temperature Kelvin, amount of substance mole, and then in luminous intensity Cd. But this we will not use in our chemistry classes, but all these will be needed in our coming chapters. Thank you all.